When we are told the size of the three sides of a triangle and we are told to decide if it's acute, right, or obtuse, we use the Pythagorean theorem to first test to see if it's happened to be a right triangle. Well, we know from past experience that the 3, 4, 5 triangle is in fact a right triangle. So that's where we're going to start. Knowing that's a right triangle, it fits the Pythagorean theorem. Now let's take the 5 up here and make it just a little bit smaller. Okay, like 4.5. Okay, so if it's 4.5, then this 3 and 4 are going to have to make a smaller angle than 90. So now we know this is smaller than 90. Let's see what happens when we use the Pythagorean theorem. Well, 3 squared, 4 squared doesn't equal 4.5 squared. In fact, it is bigger than 4.5 squared, and that is the key to showing that it's a acute triangle. If we choose the 5 and make it slightly bigger, like a 6, now we have 3 squared plus 4 squared is actually less than 36, less than 6 squared. This is definitely obtuse because the 3 and 4 have to open up in a bigger angle to get the 6 up here where the hypotenuse was. So there's the key. It's kind of the opposite of expectations. If the two small sides squared are greater than the hypotenuse thought of hypotenuse, then we get acute. And if the 3 squared, 4 squared, the two smaller sides are less than the so-called hypotenuse, now we have an obtuse angle right there. Okay, now we have three problems here, slightly different. Number 7 is actually the only one that's like this type of problem. So we're given a 30, a 40, and a 50, and if we square the small squared plus the other small squared, we get exactly equal to the 50 squared, which is in fact a right triangle. So this one here is kind of the obvious right triangle. In fact, any multiples of 3, 4, and 5, like if you took 5 times each of them, 5 times 3, 5 times 4, 5 times 5, this is also going to be a Pythagorean triple. That is called a Pythagorean triple. You might want to test first and add the two smaller sides that they give you and make sure it's bigger than the third number. That's an important concept because that would indicate, if that's not true, you don't even have a triangle. Okay, 4 and 5, we're just going to use the Pythagorean theorem. So 16 squared plus 12 squared equals the hypotenuse squared, giving us this equation, and it asks for us to supply the equation. And that means that if I square those and add them together, I get 400, which makes the x, so the x squared equals 400, and the square root of that is 20, so the x is 20. Here we have a similar problem. We can use the Pythagorean theorem. The leg, x squared plus x squared, the hypotenuse is 6. We get the given equation that we're asked to supply. This is the key here. X squared plus x squared is 2x squared. Dividing by 2, we get x squared is 18, so x is the square root of 18. If I leave it as the square root of 18, I can only get partial credit because, as you recall, we have to split that up into two square roots, and then we get a simplified answer.